Okay, well we have our soon-to-be nut mounted up in the lathe. So I'm just going to put a drill hole through in preparation for boring for the thread we have to screw cut inside. So I'll drill it and I'll part it off and we'll flip it around. We have a feature to do on the inside bore there to give some clearance for the taper, as you'll see later on, and screw cut it. So let's get our drill hole done. We'll put a bit of a chamfer on this corner. Get quick. A little bit more. That's the ticket. Okay, we'll get our nut chopped off and then we can carry on with the other features. Okay. Okay, what we're doing, we're just boring out half the depth of the nut, so we'll have clearance. So when the nut screws on its thread, one half of the nut will start on the taper to push the arbor up the length of the taper. So we need to go about 140 thou diameter to have the relief over the taper. So we'll continue on. Okay, just so we're all on the same page as where this is heading with this nut. So we have our arbor, our long shaft, this thread and the tapered section. So the lap in blue will have the same taper. It's an expanding lap, so the further it goes up the taper, the more the OD expands. So that's why we've got such a gentle taper and a very fine thread onto the nut. So hopefully that'll give us some sort of decent resolution in relation to size on the OD of the lap. So when we screw the nut up, it expands the lap. So our nut, this is a cross-section view of our nut. So we've threaded half of it, and then half of it is bored out and clearance on the taper. So to enable the lap to have some travel. So that's what we're doing at the moment, this feature here, this clearance feature in the nut. And then we'll flip it over and screw cut it. We'll see how we're going for size there. So we're 55 thou up on 1 inch. So if we go and measure up our tapered shaft approximately the same distance that we've bored in, we're about 37 thou, so that gives us plenty of clearance. We don't want any interference between the ID of the nut and the taper. And the same, we want to make sure our thread, even though it is a very fine thread, we do want to make sure we have a good couple of thou clearance, so the thread isn't influencing the way the front face of the nut contacts the lap and tries to cock it over. So we'll knock that sharp corner off, and we'll flip her over and screw cut it. Okay, we've flipped our part around now, so we've finished our clearance bore on the rear there. So now we'll screw cut the front. So we have to bore it to the screw cutting size. So all that we've done, because we're cutting a 1 inch diameter thread, our actual thread is finished as about 4 or 5 thou under 1 inch. We will deduct the double depth of the 32 TPI thread from the 1 inch diameter. So the double depth is 0.0541. So if we deduct that from 1 inch, that gives us a bore diameter of 0.946. So then, if we deduct 0.946 from 1 inch, it gives us 54 thou. And if we halve that, it gives us 27 thou, which will be the depth of our cut we plunge the tool in. Okay, I'll take a trial measurement with our telescopic gauge. We're coming up pretty close now to our thread ID that we need to be. Which is 946 thou. So what do we got left? We've got 5, 10, 11, 12, 13 thou, 13 and a half thou to come out. I think that should put us pretty well there. We're a couple of tenths under 946. Just check the rear of the hole. That's about half a thou under. That's okay, I'll just give that a polish out with some emery. That should bring us pretty well there. Yeah, that's 946, right on the knocker. Okay, we'll get set up for screw cutting. We'll cut our thread. Okay, I did have to buy a new screw cutting bar the other day. This is just a TM brand. It's probably a bit better of the cheap. Yeah, I think sometimes they work okay, so we'll give it a go. Normally my preference for this style of thing is to go for Seco or something like that, but sometimes cost prevails, so we've got the cheaper one. So we'll get it mounted up and give it a go. Now it is critical that our tool be on centre. If we're a tiny bit above, so be it, but we do not want to be below centre. So now we just have to square up the tool to the axis of the machine. So all I normally do is use the tailstock quill, wind the quill out, all the way out, and then run the boring bar, back of the boring bar up against the quill. Now we'll automatically square up the boring bar. And then we can just lock her up. So we're on centre and we're square. So we'll just check our thread cutting levers to make sure we're going to be cutting the correct pitch. Put a bit of put a Sharpie marker in there, so we'll take a scratch pass, check it, and then check it with our thread pitch indicator. So I'll just give our lead screw a quick blow off and the little gear on the thread engagement indicator. Be getting any of that rubbish that's sitting on the lead screw into the half nuts. Just give a bit of a clean off with a rag. And a bit of oil. The oil on the haft on the lead screws, the little gear screwed up into the half nuts. Put on the ways, away we go. Select a suitable speed. Okay, we'll blue the part up so we can check if we're cutting the correct pitch. Touch off to get a 0 mark. Run a cut through, check our bits. Well, it looks like 32 TPI. I think I better get the magnifying glass because it's a bit hard to see at the best of times with these fine threads, being an internal. I have to swing the light around a bit better for this one, so it might get a bit glary. Now it looks like we're cutting 32 TPI. Okay, we'll continue on. So we have a 27th thou depth of cut. I might actually just clean that Sharpie marker stuff out because it makes it a bit harder to see when it mixes with the cutting oil. This goes everywhere. Got a brake cleaner. A bit empty, that bottle. And down comes the rain again outside. Well, it is winter here in Perth. So, okay. Pretty flexible, these bars. It's a lot of spring passes I've just done. Okay, that's cut now to the required depth. So we might take a pass through to get the fur off. We'll just come out of screw cutting, back into threading. Bump our speed up a bit. should have smoothed out any fur that we had. Might need a bit of a polish out, we'll just give it a bit of a test fit. Okay, we'll check the fit of our thread now we've cleaned it all out. Just chuck a bit of oil on there. Just to we can get it to start. There we go. Well, it's feeling good. We might be on a winner here. Screws up all the way, just a slight bit of play in it. We don't want it very tight. We want a little bit of play, but not like a we don't want it like a cock in a shirt sleeve. So a little bit of play helps with alignment, self-alignment when the face of the nut comes up against our lap. So it will lessen the chance of influencing the way the lap's running on the taper. Maybe. So that's come out good. So while we've got it in here, we'll stick an indicator on it and just check our clearance, see what we have got. Let's get an indicator set up. Okay, we've just got our Federal Testmaster indicator on our shaft, just to get a bit of an indication of what sort of clearance we're looking at between the shaft and the nut. So we'll rock the shaft up and down. It's just a bit of an indication. So it's looking like 3 thou. Bear in mind this indicator is graduated in half thou intervals. So 3 thou, that's pretty good on a refined thread like this. I mean, you've only got to go a couple of thou too much on a fine thread like this, and it just seems to magnify the effect that it has. Like if this was a coarser pitched thread, 1 inch thread, like an 8 or 10 TPI, the play on having a 3 thou clearance would not have the same effect as like a little fine thread pitched thread like this has. So no, that'll be perfect. So we'll let that one go. Move on to the cast iron lapping component that we're going to make.